Hi everyone. Topic 15. Limits. We saw in the previous lesson that in order to find the slope of tangent line, okay, or for example, a speed at certain time, okay, not average speed, we need to know limit. We saw that. So here I'm going to define limit, and I'm going to show you several just type of limits, and then we can just talk about how we can find limits for some certain functions. Okay, so if I say limit of fx when x approaches to a, so let me just maybe zoom in. Okay, so when x is approaches to a is L, I show it this way. So just one second. Okay, so I show it this way. Okay, we show this. Means when x is approaching to a, fx is approaching to L. Okay, so when I see this here, means from both sides, if I have a here, from both sides when x is approaching to it, for example, this is my graph. Okay, so I can see fx is approaching to, for example, L. Okay, I accept that when I say this, when I talk about limit, x is not a and fx is not L. Just x is approaching to a, very, very close to a, and fx is very, very close to L. But it doesn't mean it's exactly L at a. Maybe yes, maybe no. I can show you several types. I really like you to understand. I don't want you to memorize. So the first one here, look at this. What does this mean? See, when you look at this here, you can see this one means limit of fx when x approaches to a is L. Why? Because I can see when x is approaching to a from both sides, on the graph we are approaching to this point, which is L here. Okay, if I ask you what is f at L, what is f at L, you say, sorry, what is f at a? Okay, f at a is L, but this doesn't have anything to do with the limit. Okay, the next one, x is approaching to a, fx is approaching to this point that when I go here it's L. So limit fx is L when x approaches to a. These are all together. I cannot remove them from the thing. When I talk about limit, I need to have limit. I need to have x approaches to what number. Okay. So what is the difference? What is the difference between this and the first one? Okay, what is the difference between these two? Oops. So all of a sudden, maybe I have to use it. Yeah. What is the difference? Okay. When I look at the two graphs, I see f at a is L for graph number 5, but for graph number 4, f at a is not L. F at a is M. Doesn't matter. Still, limit is L when x approaches to a. Okay. How about graph 3? Okay, so I couldn't find a picture that has all of them. So just to go from graph number 1 to 5. So this is that we have all just another way. Okay, so we go from 5 to 1. Okay, so here, okay, I can do this. Okay, look at this. If I go to, if x approaches to a, if x approaches to a, I can see fx is approaching to L. Oh, okay, so here also I have the same thing. Limit fx is L when x is approaching to a, because when x is approaching to a, okay, I can see fx is approaching to this point, which is L. But then I ask you, what is fa? F at a. Okay, f at a is an empty point. Okay, so does not exist. Here f at a is m. Okay, so here f at a is m. Okay, so which I can say that. But in all cases, in 3 cases so far, limit exists. Limit exists and limit is L. How about here? I can see when x is approaching to a, fx is approaching to just ceiling, for example, means fx is approaching to infinity. So limit fx, x is approaching to a, and the answer is just going up and continues to up. So it's infinity. Okay. How about this one? The last one. Okay, the last one. When x is approaching to a, okay, I can see something is happening on left side, something is happening on right side. Okay, so what should I say in this case? Okay, x from right is approaching to a, means from more values approaching to a. I can see this guy is approaching to this point. On the other hand, I have x is approaching to a from left side. I can see fx is approaching to this point. And this point is not the same as this point. No. Okay, so I can write this. Limit, I can write this. Limit fx, x is approaching to a from values more than a, is not the same as limit when x is approaching to a from left side. It's not the same as each other. Can I say both of them exist? Yes, both of them exist. So I can say right limit exists, left limit exists, but limit doesn't exist because they are not the same as each other. So limit of fx when x is approaching to a does not exist. Okay, so I found this picture just from this website, and so all from different websites. So I didn't create them, but I just wanted you to see different type. Okay, I can have like graph 5, which is smooth, all connected. I have limit, I have f at a, all of them the same as each other. I can have like this, which limit exists, but at that point fa is another value. I can have this, limit exists, but fa doesn't exist at all, so it's empty point. I can see here the limit is infinity, so the value is infinity of the answer. So x is approaching to a, it's going up, 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 up. Maybe in some cases, when x is approaching to a from right side going to infinity, from left side going to minus infinity. I can show you. And graph number 1, limit of left side, which is this, exist, right side exist, but both of them are not equal, so limit doesn't exist. But just left side and right side, yes. Okay? So, now that you saw all of this, I want to write this. If I have limit fx, x goes to a from values less than a, and limit fx, x goes to a from value more than a, are both of them the same, I can say limit of fx, if both of them exist and both of them are L, for example, a value on real number set, I can say limit of fx when x approaches to a exist. Okay, I can say exist and it's L. But if I have both of them which are not equal with each other, like graph number 1, okay, no, limit doesn't exist. Okay, so I really wanted you to see lesson number 14 to know what's the reason I know limit, I need limit, because in many cases, based on my experience, a student asks me, what is the reason I need to know limit? Why should I bother to know limit? So, topic 14 tells you why. And this one, at the beginning, I really wanted you to understand what's going on, not just memorize and do something and do some questions. Yes, you do questions, you practice, and you pass the course. But then you don't remember. Everything is very not clear. Okay, I try my best. Okay, so then I can say, okay, how can I find the answer for limit? I always like to have this situation. I like to have limit the same as the value exactly when I substitute a for x in f. Okay, so one more time. I always like to have this part like this, graph number 5. When I put a as x in f, it's L, and the result of limit is also L. Okay, so I like to have that. So that's why my strategy is this. When I give you a limit, always make sure that you put a inside x. When you find the answer, maybe that can be answer of the limit. In many cases, yes. So in many cases, we have like graph number 5. So if I substitute a as x in f, then that's exactly the limit. Okay. So, lesson. Substitution. Substitution is the first method of evaluation. You substitute. Even if you go to simplifying and cancelling to find the limit, which is number 2, at the beginning you have to substitute. So you always have to substitute at the beginning. Okay, so let's substitute here. Okay, so when I substitute here, it is cube root of 25 plus 10 minus 8, which is cube root of 27 minus 8, 35 minus 8, which is cube root of 27, which is 3. Okay, so when I substitute, I find the answer. So I can say that's the answer of the limit, because if I graph it, I can see when x approaches. So when exists, okay. So this when exists that number, okay. So that can be the answer. This method that can be the answer for the limit. Okay. So I substitute. If I find the answer as a real number, that's my answer for the limit. So I can say limit of cube root of x squared plus 2x minus 8 x approaches to 5 is 3. Yes, this is like graph number 5, last page, previous page. This method is very good when you don't have denominator. Yes, when denominator is not 0. If denominator is 0 or you have denominator, then no, then something happens because I have divided by 0 and I can't. I cannot have any real number answer. Okay, so this one. Oh, here, there is no denominator. Oh, perfect. Let's substitute. Okay, I substitute. 2 cubed plus 2 squared minus 2 multiple 2 minus 8, which is 8 plus 4 minus 8, which is 0. Okay? I substitute. I can see a real number answer. So, limit of this at that number is 0. This is like graph number 5. Okay, so how about this? Oh, here I see fractions, but denominator is not 0 at 2. Okay, so I can substitute again. And remember, I always have to substitute at the beginning. Okay, so this is 16 minus 6 plus 1, which is divided by 4, this. Okay, that 11 divided by 4. Okay, so this is the limit. This is the answer of the limit, because when I substitute, I can see a real number answer. So if I don't have denominator, if denominator is not 0, this is a good method. Okay, how about this? Okay, I have radical, but with minus 4, under radical is not negative. Do you remember? Under radical, I cannot have negative. But when I substitute, it's not negative. Oh, okay, so it doesn't matter. I have answer here. Okay, so it is minus 4 power 4 plus 2 minus 4 squared, which is this 256 plus 32, which is radical 288. If I leave it this way, I have exact number. I can also simplify my radical. If I don't, so I say, okay, 4 significant digit. I say, okay, this is 16.970, which is 16.97. That's the answer. Okay? Okay. So, now I want to show you the second method after substitution. But before I show you the second method after substitution, I like to say what's the reason you need this. I always like to say what's the reason you need this. So, limit x squared minus 1 over x minus 1, x approaches to 1. For example, if I give you this, then you would say, okay, so I substitute, yes? So 1 minus 1 over 1 minus 1, which is 0 over 0. Oh, if I have 0 over 0, then it's not clear. Okay, I don't say it's not defined, because this is limit. So, I know, x is not 1, and this one, the top and bottom, is not 0, just both of them approach to 0. Top and bottom approach to 0, x approaches to 1. So, x is not 1, x just approaches to 1. X squared minus 1 approaches to 0, x minus 1 approaches to 0. That's why I say this is not clear. Oh, okay, so what should I do? I substitute, but I see it's not clear. What should I do? That's why I need to know the lesson that I'm going to teach you now. Okay, so if you see 0 over 0, you can simplify by factoring. You can factor top and bottom, and you can cancel what is bothering you, what is making 0 over 0. That's what I mean. Okay, so x squared minus a squared. I have to tell you, and I have to remind, x minus a multiple x plus a. Do you remember? How about this? Okay, x squared minus x cube, power 4, this is x minus a multiple x plus a multiple x squared plus a squared. Okay, so this. So now, so I first substitute. Okay, what happened when I substitute? Let me just make this line here. Okay, so I first substitute the line, so not straight, yeah, okay. First I substitute. What happened when I substitute? Okay, minus 2, oops, minus 2 plus 2 over minus 2 squared minus 4, which is 0 over 0. This is not clear. Remember, x approaches to minus 2, top and bottom approaches to 0. They approach to 0. Okay, it's not 0 exactly. If I have 0 exactly, I say this is not defined. But here, not clear. Oh, what should I do? Listen, if I can factor, okay, top and bottom, see, it's talking about there are 4 main different approaches. So, factor, okay, I'm going to show you. Conjugate, I'm going to show you. Common denominator, I'm going to show you. Expanding, I'm going to show you all of them. Right now, I'm going to show you this one by factoring. Okay, so you factor top and bottom. Can I factor top? No. Can I factor bottom? Yes. X minus 2 multiple x plus 2. I told you before, in just one case I can cancel. In just one case I can cancel x plus 2 and x plus 2 from top and bottom, because I am dividing top and bottom with x plus 2. But if I have divided by 0, I cannot. But I know x approaches to minus 2. So x is not minus 2, just approaches. And x plus 2 is not 0, just approaches to 0. Okay, so it's very close to 0. Okay, it's a number very close to 0. That's why I can cancel top and bottom, because if I have 0 top and bottom, I cannot cancel. Oh, okay, okay, so I clear that problem. See, I had a situation which was not clear, so now I remove the problem which was making not clear. Okay, so this is limit 1 over x minus 2, x approaches to minus 2, yes, x approaches to minus 2, which is 1 divided by minus 4, which is minus 1 over 4. Okay, done. See, I found the answer. How about this one? Oh, how about this one? When I substitute, it is 1 minus 3 plus 2, 1 minus 1, which is 0 over 0. Oh, it's not clear. Not clear. So what should I do? Oh, can I factor top and bottom? Yes. Limit x minus 1 multiple x plus 2, no, minus 2, sorry, divided by x minus 1. X approaches to 1. See, I can give you a clue. How do I know the top is x minus 1 multiple x minus 2? See, when I see x minus 1 here in the denominator, I am sure x minus 1 exists top, because it's making 0 over 0. When I see x plus 2 top here, I am sure x plus 2 exists in the denominator, because it's making 0 over 0. That's why. So when I know x is approaching to 1, x is not 1. So x minus 1 is not 0. So I can cancel this and this. So it is limit x minus 2, x approaches to 1. So you don't need to talk about these things. You can just do it. Okay, this is minus 1 is the answer. Oh, okay, I found. What type of questions are these? Okay, these questions that I'm doing now, they are very similar to this. They are very similar to graph 3. Limit exists, but at that point, limit doesn't exist, like graph number 3. At that point, limit doesn't exist. When I substitute, limit doesn't exist. When I substitute, it doesn't exist, but limit exists. So like graph number 3. Okay? So, one more. Okay. So I substitute. I substitute, I see, oops. I substitute, I see 3 squared minus 2 multiple 3 minus 3 divided by 3 squared minus 4 multiple 3 plus 3 which is 9 minus 6 minus 3, which is 9 minus 12 plus 3. So I have 0, so it's 9 minus 9, so I have to calculate to show. It is 12 minus 12, which is 0 over 0. Done. Oh, it's not clear. What can I do? Okay, I am sure something is bothering top and bottom, so I can cancel. So I factor. Limit. Can I factor top? Yes. X minus 3 multiple x plus 1. Yes. And x approaches to 3. Another clue is this. When x is approaching to 3, for sure I have x minus 3 top and bottom. Okay? So here I don't see, look at this. Here I see this yellow one and I can factor. But here I don't see. So I can say, oh, for sure x minus 1 exists in top and bottom because x approaches to 3 and I have 0 over 0. Oh, okay, so it is x minus 3 times x plus, x minus 1. Yes. This and this cancel. So it is limit x plus 1 over x minus 1, x approaches to 3, which is 3 plus 1, 3 minus 1, which is, which is 4 over 2. It is 4 over 2, which is 2. Okay? So the limit is 2. So the answer is 2. Okay? So this is the answer. I write 2 here. OneNote is almost killing me. Okay. So minus 1 over 4 minus 1. Minus 1 over 4 and so minus 1, so which we found it later. Okay, so yeah, yes. Okay, so I do this. Okay, so I do this equal minus 1 because I found it at the end, but when I started, so I did this 1 minus 3 plus 2 divided by 1 minus 1, which is, and then I went to this part. Yeah. So how about this one? Okay, this one, it is 49. Okay, so equal 49 minus 7 squared minus 7 squared minus 7 plus 7, which is 49 minus 49 over 0, which is 0 over 0. Oh my goodness. 0 over 0 again. So can I factor? Oh yes, I notice I can factor. That's so remember, factoring, maybe you have to do common factoring, maybe you have to do difference squared like here, or maybe you have to do trinomial factoring. You have to know review number 2, and that's for example 3 that I did. Okay, so it is limit 7 minus x multiple 7 plus x divided by x plus 7, and x approaches to minus 7. Okay, okay, so can I cancel this? Yes, I can cancel this and this. It is equal limit, so 7 minus x, x approaches to minus 7. See, it is not bothering me anymore. Okay, so the answer is 7 minus minus 7, which is 14. This is the answer. Okay, that's 14. So far so good. Okay, so I stop here, and then I stop here, and then I continue in the next video. Thank you so much. Bye.